Very good afternoon to one and all present here. I'm Ajit Kumar. I'm from L&T Construction Solar Business. We are into construction of utility scale solar plants and also large rooftop solar plants across India. This work is based on my master's research at NIT Trichy. I worked along with Dr. M.P. Selvan from the Department of Electrical and Electronics Engineering at NIT Trichy, along with Mr. K. Rajapandian, who is my colleague in L&T Solar. The topic for the presentation is the grid stability analysis for high penetration solar photovoltaics with Indian context. The agenda, this is going to be the flow of my presentation. I'll start with an introduction and a brief on solar in India. A brief discussion on controls existing in the conventional plants to manage grid stability. This would be useful in determining the requirements for upcoming large solar PV plants in India. I'll jump into the research, the methodology used, the steady state analysis and transient stability analysis, and finish with conclusions. Yeah. The renewable energy is a buzzword. The growing global energy needs and the need for the environmental friendly and the sustainable growth has made us focus on renewable energy resources, especially when it comes to large scale wind and solar as proven. RES, when implemented in large scale, will without any specialized controls, is found to impact the grid, the integrity, reliability, and the stability and security of the grid. Solar PV penetration into the grid is on continuous rise because of the certain advantages offered by solar PV compared to other renewable resources. So it is being installed in large scale, and single plant of large single units of hundreds of megawatts is coming up in India, and it has come up at a global level. Such large utility plants are, since they are bulk in capacity, they are expected to behave like their conventional counterparts in terms of managing grid stability, so that they do not impact grid negatively in terms of its security and reliability. Problem statement. Until now in India, the solar PV installations are connected at only distribution level until recently, but large solar parks of hundreds of megawatts are coming up and they are connected at transmission level. So solar PV, unlike other thermal plants, are asynchronously integrated to the grid through inverter, and so hence they do not contribute for grid inertia. It is a significant aspect of the other conventional counterparts, wherein they have the grid inertia, which is the primary response for the frequency stability. At present, the solar PV's anti-islanding protection will trip the plant immediately whenever there is a grid disturbance. Even though plants installed in India recently have advanced controls like LVRT and other dynamic grid support controls, but they are not operational as the utility is not mandating it. But as I know, so islanding protection will immediately trip, and when the capacity of the plant is large and the plant is tripping for a grid disturbance, that will cause a huge impact on the grid, and it will affect the generation load balance. Also, when the plant capacity is large, the seasonal and weather variations will affect the like partial clouding will immediately bring down the supply, and it will also when the plant capacity is large, such variations will affect the grid negatively when it is large. These are the objectives and that went on what driven us to do the project. So in Indian scenario, the large solar plants are coming up, and the government support and the policy framework in India is promoting large solar power. Hence, there was a need and requirement in analyzing the impact of large solar PV into the grid. To understand the requirements of large solar plants, A brief study was conducted on the existing conventional plants, how they are managing grid stability, so that we can expect the the requirements of the future solar PV plants that need to be accommodated. And brief literature survey was done on the drawbacks and impact of high PV penetration levels. That is, you can refer the full paper for the details. This research was focused on analyzing the solar PV integrated into the standard bus system, how it is impacting the grid. We focused on steady state performance and transient stability performance for the analysis. As you all know, the renewable installations being the order of the day, and the government's trust in promoting renewable energy throughout the country. The total penetration of solar is increasing at a rapid pace, and at present the share is about 3.98%, and in 2022 it would be 23%, which is very huge. 100 gigawatt out of the 4,34,900 megawatt. This is based on the CA and MNRE data. The controls existing in the conventional plants in India, especially to manage frequency stability and active power control, the initial response is given by the inertial response of the conventional generators. And in the control phase, there are three actions: primary control, secondary, and tertiary. Primary is achieved by our turbine speed governor system and automatic load frequency control and restricted governor mode of operation in place in India. And which gives us the requirement for speed droop characteristics. And secondary control is achieved by automatic generation control, which is being implemented in India. And there is also tertiary control. For angle stability, there are power system stabilizers as part of the excitation system to improve small signal stability in the conventional plants. To improve voltage stability and reactive power control, there is automatic voltage regulators as part of the excitation system. If it is kept in voltage control mode, it will contribute for steady state voltage regulation, and if it's kept in VAR mode, it will compensate for reactive power both under excitation or over excitation, whichever is required. So, and the voltage profile improvement can also be achieved by the on-load and off-load tap changing transformers, which are present in conventional plants. Such requirements are not existing in the current large solar plants in India. These are the main essential characteristics which are required out of the upcoming large solar plants in India especially. The methodology that went behind the research was, so for studies, we considered a standard bus system, which is IEEE 9 bus system for the analysis. Due to lack of data, we couldn't go about with the real-time grid system. So the load flow, the steady state voltages were observed, and the loading effect and the system losses in the transmission were observed by increasing the penetration in the standard system. And transient stability analysis also was done. Especially 4 cases was dealt. And the effect on the 4 transient cases were dealt. One was tripping of a bus. Another one is a loss of a transmission line. And the effect on the critical clearing time due to PV penetration was also done. And the effect due to load rejection was done. This is the test system which we considered for our study. This is a standard IEEE 9 bus system wherein there are 3 synchronous generators. G1 is about 240 megawatt, which is modeled as swing bus. There are 2 other synchronous generators which is modeled as PV bus. There are 3 major loads and the transmission lines connecting them. These are the simple load flow result of the standard system which we used for further analysis. The 9 bus system was integrated with the solar plant, which has got individual modules or individual blocks of, say, 22 megawatt each roughly. The individual blocks are continuously switched, and the effect was observed one by one, right from 0 to 100% of that block. It is integrated to bus number 5 initially, and then switched to several other buses, and the effect was observed. The steady state voltages were observed across the buses, and it is plotted against the penetration percentage. This is the plot of voltage versus the penetration, solar penetration for and for various buses. The case 1 is the penetration at bus number 5. In the case, and the case 2 is for the penetration at bus number 6, and the case 3 is for penetration at bus number 8. The bus voltages, except for the PV buses, improved with increase in the penetration, and it to a point, till a point, and then beyond certain penetration, it started dipping. The intensity of the voltage variation also varied with the location of the penetration, and the maximum of the variation in bus voltage observed in all 3 cases are listed. Case 3 was severe with 8.35% variation in the bus number 5. So the peak point of the curve also was varying with the location of penetration. So it is seen from the study that among the 3 cases, PV injection at bus 5 was better, and it allowed for more penetration with less severe variation in voltages. This is the effect on the system loss. As the penetration was increasing, the the transmission losses decreased till a point, and beyond a certain point, it started increasing. This is a plot of the real power and both reactive power losses with respect to increase in penetration. So optimal penetration level can be identified with respect to system losses, and also the best location for the penetration can also be identified from this. This is the effect of loading of the transmission lines as the penetration was increasing from 0 to 100. The variation is kind of mixed. In some transmission line, it increased. It experienced increase in power. In a certain transmission line, there was decrease in power, which there was even power reversal happen in few lines. So it is very critical to plan the system. We have to consider these loading effects before identifying the proper bus for solar injection. So from the steady state, the summary of the steady state analysis, it was identified that bus 5 was the best bus for penetration based on the steady state voltage study and the system loss study, and the maximum possible penetration was 66 and 44 respectively. So it might bring about severe changes in the other parameters like steady state, real power, reactive power, loading of the transmission lines, and other equipment in the system also affecting the system losses. So it is important in performing such a study, which will help engineers in planning the system with high levels of PV penetration and identifying the critical PV penetration for that particular considered system. Next, I will move on to transient analysis. The effect on critical clearing time was dealt first. As the penetration was, same system was considered with penetration at bus 5. As the penetration was increasing, the critical clearing time of the system was coming down, and beyond 20% penetration, the system was getting unstable. So the cases till 20% penetration was considered. So hence, it is very important, and this will impact on the power system protection aspects of planning. So the critical clearing time was coming down, and so it is very important to plan the protection aspects, and high-speed circuit breakers might be required in this case is like of high PV penetration. The bus fault was simulated, and the case with one particular bus in the system, the bus fault was simulated, and it is cleared. The rotor angles of the generator were observed to see if they are to check for the synchronism. The for 3 cases are plotted. For the 0, 30, and 10 penetration cases are there. For the 0%, it is fine. After the fault, it is converging, and rotor angles were converging, and the system was in synchronism. Whereas it was the oscillations were increasing for more percentage. And then for 30% case, it was getting severe, and the system was going out of synchronism. A similar effect was observed in generator 3 also. The system was getting unstable beyond 20% penetration. The voltages at the buses, voltage plot of the buses post fault is plotted here for 3 penetration cases, which was discussed earlier. Here also, for the 30% penetration case, the oscillations were getting unstable, and it was going beyond synchronism after a certain penetration level. So here also the 20% penetration is the maximum limit achievable. This is a case for this is the plot for the transient case, where a large load was removed from the system. The transient disturbance due to the load rejection is considered. Here also, until 20% only they were able to penetrate accommodate the solar power in that system. This is the voltage plot for voltage at bus 5 and bus 9 for the same case, in effect due to load rejection. Third transient case which was considered was the effect due to the loss of a transmission line. This due to the post-fault performance is plotted. The oscillations were observed, and here also the same results were obtained, wherein the oscillations for the 30% solar penetration case, the oscillations were more and is not converging to a stable value, which was forcing the system to go out of synchronism. This is a voltage plot. Again, it was similar to the previous case. So, a summary of the transient stability analysis. In all the case studies, the system was getting unstable for transient disturbance as the level of penetration was increasing. The bus voltage magnitudes and the relative rotor angle, and hence the synchronism was the most adversely affected parameters with high penetration PV. It is very important in taking into account the transient performance of the system with high PV penetration levels to maintain the system integrity and stability following faults. And as we know, the system inertia is very less in systems with high PV penetration, leading to severe issue following various system disturbances. To conclude, large penetration of solar PV will impact the grid at various levels, especially the grid stability. The increased penetration of solar PV into grid without any specialized controls has been proven to affect both steady state performance and transient stability performance of the grid through the analysis done. So control mechanisms are required from the upcoming large solar PV plants in India for grid support, like dynamic grid support, and active and reactive power, and there are other controls which needs to be present in large PV plants in India, which is not, few inverters are having the capability, but they are not operational. There's only anti-landing protection, which is at present being followed in large plants. So this study is important in planning the system with high PV penetration levels of solar PV power and identifying the critical PV penetration levels for a given network. Future similar studies should be done for an actual Indian grid at both national and regional levels. The effects due to clouding is not covered in this study. That could also be done and studied and analyzed from the plant side. The disturbances from the plant side, how it is affecting the grid performance, can also be studied. As mentioned earlier in the earlier presentations, models with solar models with a dynamic grid support capability, fault rate through capability, all those things has to be developed, and their impact or effectiveness in managing grid stability can be analyzed further. Thank you.